of all, we have two curves, one of which is y equals 4x minus x squared, and one of which is y equals x squared minus 4x plus 6. And it's useful to know which one's which. If we've got a negative x squared term, which means that we have this shaped curve, a sad parabola if you like, and if we have a positive x squared term, it means that we have this shape. So this curve here, the upper one, is y equals x squared minus 4x plus 6, and the lower one is y equals 4x minus x squared. Now, to find out where those two curves intersect, we need to solve the two equations simultaneously. And in order to do that, I just need to put the two equations together. And that's fairly easy to do here because they're both in terms of y, so that I can just write that x squared minus 4x plus 6 will equal 4x minus x squared. Now it's a quadratic equation, so I'm going to make the right hand side 0 by adding x squared to both sides. So this becomes 2x squared, by subtracting 4x from both sides, so this becomes minus 8x plus 6 is equal to 0. And in fact I can see that if I divide the whole lot by 2, I've now got x squared minus 4x plus 3 is equal to 0, which is a bit easier to factorize. If I now factorize, then I'm going to have x and x, two numbers that multiply to make 3. Well, it's going to have to be 3 and 1, but they're both going to have to be negative so that I get minus 4x. And the solution to that, or the solutions, are x equals 3 and x is equal to 1. So what that means is that at this point here, x must be 1, and at this point here, x must be 3. Now, to find the area enclosed by the two curves, the easiest way to do that is find the area under the top curve and subtract the area under the bottom curve. And you can do that together and have it as just one integral. Now, the limits are going to be 1 to 3 because I want the area under this curve between 1 and 3, so that would give me this area, and I want to take away this area here. So it's the integral from 1 to 3. Now, the upper curve, as we established earlier, is 4x minus x squared. So 4x minus x squared. Now you can work out this integral with respect to x and then take away the area under the lower one, but actually you can do that all together as 4x minus x squared take away x squared minus 4x plus 6. It just makes the working a bit simpler, and I can simplify at this stage. So the integral from 1 to 3, if I do minus x squared, well that's minus 2x squared, 4x minus 4x, well that's plus 8x, and then that's minus 6. So I'd have to just do a little bit less integration. Okay, I'm now going to integrate each of those in turn. Well, that's going to become x cubed. I'm going to divide by 3, so it becomes minus 2/3 x cubed. 8x becomes x squared, and that's going to be multiplied by 4, so that when I differentiate I get 8x, and then minus 6, when I integrate it, becomes minus 6x, and that's from 1 to 3. Okay, I'm now going to start substituting in, and first of all I'm going to substitute in the top upper limit. So I'm going to do minus 2/3 times 3 cubed plus 4 times 3 squared minus 6 times 3. I'll worry about that in a minute. And I'm going to subtract. Well, if I substitute 1 into each of these, the first term is just going to be minus 2/3. The next one is 4, and the last one is minus 6. Okay, let's carry on. So I'm going to do minus 2/3 of 27 plus 4 times 9, well that's 36, minus 6 threes, well that's 18, and then minus, now if I do 4 take away 6, well that's minus 2, minus 2/3 is minus 2 and 2/3. If I keep going, well 2/3 of 27, a third of 27 is 9, so 2/3 of 27 is 18, so this becomes minus 18 plus 36 minus 18, and then this minus 2/3 becomes plus 2 and 2/3. Now I can see here minus 18 is actually minus 36. Minus 36 plus 36 is actually just 0. So it's 0 plus 2 and 2/3, which is just 2 and 2/3. So the area between the two curves,